Okay, Chase. Welcome to the second video. I'm going to be doing question 5 on your example exam that you sent me. So the first one says integrate the following in terms of x. So this is 5.1. And they say do the integral of 3 sine 3x minus e to the minus 4x minus 3x to the minus 4 plus 2 times 3 to the 5x minus cosec squared x plus 2 dx. Okay, this looks like a really hard integral, but let's be real, we both know that it's just a whole bunch of really simple integrals grouped together. So we can integrate once again each term, just like that derivative. We integrate each term individually and we can just add up our answers right at the end. Okay, so let's get cracking. The integral of sine of 3x is integral of sine of 3x is negative cos of 3x. You would probably have done this by use substitution. The reason I don't need to is because I've done it by inspection, just by saying, well, if I differentiate negative cos 3x, what am I going to get? I'm going to get 3 sine 3x. So I know that negative cos 3x is the integral. Next, let's integrate this term. So minus e to the minus 4x. Well, the integral of that is minus e to the minus 4x over 4. Once again, how do I know that? Well, if I take the derivative of e to the minus 4x, I'm going to get minus 4e to the minus 4x. Oh, sorry, I need to put that there. Let me just check. No, it's over 4. No, so this is a plus here. Okay, so if I differentiate this top piece, the e to the minus 4x, I get minus 4e to the minus 4x. So if I divide that by 4, I'm going to be left with that. Once again, you could just do this by use substitution. I'm just doing it by inspection because it's a bit faster. Okay, then let's integrate this term. Minus 3x to the minus 4. That's quite an easy one because we know, what do? We've got ax to the n, and the integral is, what was our integral? Our integral is ax to the n plus 1 over n plus 1. So we're left with minus 3x to the minus 3 over minus 3. Right? Next we've got plus 2 times 3 to the 5x. Okay? So if we integrate 3 to the 5x, we are going to have 3 to the 5x over 5. Because if we differentiate that, if we differentiate our top term, it gives 3 to the 5x times 5. Hang on, that might be a mistake there. That one's not true, sorry. Let's just go check our integral formulas here, integral table. I'm lying to you here. Integration. I wish I had the full table in front of me, but unfortunately I have to page through your book, which is a bit annoying. Okay. So, the integral of a to the x is a to the x over ln a plus c. Okay, so in this case, we've got 2 times the integral of a to the x is a to the x, so 3 to the 5x over ln of 3, okay, and we need to multiply by 5 because we've got this 5 here. This, once again, you'll have to do this one by substitution until you get comfortable with integrals. And you will have done this by substitution and gotten the same answer. Yeah, anyhow, continuing onwards. Next we've got the integral of negative cosec squared x. And I need to check that one as well because I'm actually not sure. I think you see this will be on your table of integrals and it'll be easier. Let's just check. Okay, it should be in your table, or you can do it by whatever method you want, but the integral of negative cosec squared x is going to be positive cot x, okay, and then we move on to our last term, which is the plus 2. The integral of 2 is 2x. Sorry. This integral sign should have never been carried because I've done the integration in this line. And then right at the end we get our plus c, which you mustn't forget. So let's just quickly simplify. So we've got negative cos 3x plus e to the minus 4x over 4. That cancels with that and we're left with plus x to the minus 3 plus 10 times 3 to the 5x over ln of 3 plus cot x plus 2x plus c. That should be your final answer. Yeah, I believe that that is correct. I'm just going to pause the video and double check because this was a long integral. Or actually, I'll double check just by inspection here. You can listen while I do it. Okay, so if we differentiate minus cos x, we get, well, the derivative of cos x is minus sine x. Okay, so that is fine. And we differentiate this, we get minus sine x times 3. So that is correct. Right. If we differentiate e to the minus 4x, we get e to the minus 4x times 4. So we are fine, times minus 4. So we are fine over there. Okay. If we differentiate this, we get minus 3 minus 3x to the minus 4 over minus 3. Yeah, that is correct. Then here we get, if we differentiate this, we get 3 to the 5x ln 5, or 3 to the 5x ln 3 times 5. So we divide by ln 3. This might be a mistake here. Hang on. This should be a divide by 5. See, this is why we check our work. So this 5 should probably be here. Because if we take d by dx of 3 to the 5x is equal to 3 to the 5 to the 5x over, sorry, 3 to the 5x ln 3 times 5. 5 times 3. So we need to divide by 5 and divide by ln x, and then we end up with, yes. Okay, so this is correct. Okay, the integral of negative cosec squared x is, well, the integral of cosec squared is cot x, so the integral of negative cosec squared is negative cot x. The integral of 2 is 2x, and we have our plus c. So that answer is correct except for this term, which is wrong. So this term, sorry, let me correct, that term becomes 2 times 3 to the 5x over 5 ln 3. Okay, and there, that is your final answer, and it is now checked and ready to go. Okay. Alright, our next question is 5.2. 5.2, and it says, determine the integral from 1 to 2 of 2 to the minus 5x dx. Okay, integral from 1 to 2 of 2 to the minus 5x dx. Okay, so that is equal to the integral of 2 to the minus 5x is, let's just double check, I don't want to make a mistake. As I said, it's useful, very useful to have that integration table given to you. It really helps. Here we go. Okay, the integral of a to the x, so here's a to the x, is a to the x over ln a. So we've got 2 to the minus 5x over ln 2, and we've also got to put in our minus 5 at the bottom here. So that is our integral, and we need to evaluate that from the points 1 to 2. Okay, and let's quickly type that in. Now, you would have done this by u substitution once again. So you would have said the integral from 1 to 2 of 2 to the minus 5x dx. Then we say let u equal. Let u equal minus 5x. Then du by dx is equal to minus 5. Then dx equals du over minus 5. So then we have the integral from 1 to 2 of 2 to the u times du over minus 5, which is equal to negative 1 over 5. Negative 1 over 5, the integral of 2 to the u is 2 to the u over ln 2, ln of 2, from 1 to 2, right? And then we need to substitute back and put it in terms of x, so minus 1 over 5, 2 to the minus 5x over ln of 2, evaluated from 1 to 2, which is equal to 2 to the minus 5x over minus 5 ln 2, evaluated from 1 to 2. And you see how those answers are the same, so I wasn't lying to you. Okay, so let's quickly evaluate those points by popping it into the calculator. 2 to the minus 5 times 2 over minus 5 times ln 2. Okay, so we're doing final minus initial. So let me actually write it out for you, sorry. 2 to the 5 times 2 over minus 5 ln 2 minus 2 to the minus 5 over minus 5 ln 2 equals. Okay, so I've evaluated the first term as minus 2,82 times 10 to the negative 4 minus. And then let's pop in, we substitute in 1, so we're going to do this one. So we substitute in 1 for x and we calculate this point, which is going to give us 9,02 times 10 to the negative 3. And if we do the subtraction, minus 2.82 times 10 to the negative 4 plus 9.02 times 10 to the negative 3 is 8,74 times 10 to the negative 3. Bam! And there's your final answer. Okay. Sketch and, okay, so let's do 5.3.1, right? Sketch and indicate the area enclosed by the graph y equals 4 cos x. Okay, so sketch and indicate the area enclosed by the graph y equals 4 cos x, the x-axis, x equals 0 and x equals pi over 2. So that is, they're basically saying draw it from x equals 0 to x equals pi over 2. Pi over 2 is 90 degrees, by the way. Also indicate the representative strip used to calculate the area of the enclosed area. Okay, so basically what they're saying is draw the graph y equals 4 cos x, and 4 cos x looks a little bit like this, and so on. Okay, this value is 4. This value here is minus 4. And this is, that is pi over 2. This is pi. And this is 3 pi over 2. And this value is 2 pi, right? Okay. So they're saying indicate the area between x equals 0 and x equals pi over 2 on the x-axis. So that area is this piece here. Right? And then they say also indicate the representative strip to be used to calculate the area. I'm not sure exactly what they mean, but I think what they're saying is the representative strip is this piece to this piece, which is 0 to pi over 2. And you might want to label that as representative strip. I think that's what they mean. I'm not entirely sure what they're actually asking for in that question, but I think that's fine. Okay, then question 5.3.2. I wish I had done it a bit smaller. Let me try write. I'm going to try solve this problem here. So question 5.3.2 says, calculate using integration the value of the enclosed area indicated in question 5.3.1. So basically what they're saying is take the integral from 0 to pi over 2 of 4 cos x dx. Okay, so the integral of 4 cos x is equal to 4 sine of x evaluated from 0 to pi over 2. Okay, and that is equal to 4 sine pi over 2 minus 4 sine of 0. And if we substitute in, sine at pi over 2 is 1, so that should be 4, minus sine at 0 is 0, and our answer is 4. And you might want to say units squared, or units of area, because I noticed that they do like to do that in your book. Just want to check. Yeah, I just want to check now that I haven't made any mistakes with any integrals. I hope not, because I do sometimes make stupid mistakes with integrals. So if you spot anything that you think I made a mistake on, just let me know. I hope not, because that would suck. But yeah, this integral is fine. So that's your answer to question 5.3.2 is 4 units of area. Okay. And then your last one is question 5.4. 5.4, and it just says simplify, or basically do the integral of 1 over cosec x dx. Right, so this is a bit more of a tricky one. What if this is a nice U substitution example, because we know how excuse me. Oh wait, this is, sorry, I'm being stupid. This is actually a very easy one. Okay, 1 over cosec x is equal to what? 1 over cosec x is sine x. Okay, so 1 over cosec x is equal to sine x. I believe. I just want to double check that. Yeah, 1 over cosec x is equal to sine x. Okay, so this is equal to the integral of sine x dx, and the integral of sine x is negative cos x plus c. Done. Okay, so this was just a simple little trig identity, no big deal whatsoever. And there you have it. There's the answers to your questions. I know you just asked me to do the working out, but I thought I'd run you through a video. I know I didn't explain everything in great detail, but I think that this will give you a better idea of the working out than if I had just done it on paper and given you the answers. So yeah, I hope that this helped. And yeah, good luck with your studies. Have a great day, man. Cheers.